today we're going to be doing 10.5, and we're going to do a couple Venn diagrams in order to do a two-way table. And then off of a two-way table, we can do a relative frequency table. So after today, I can make a Venn diagram, I can make a two-way table, and I can make a relative frequency table. All right, so you've already had the vocabulary brought up. You're going to want to pause it if you're watching it online so you can write these down. The underlined things for sure written down. Categorical data, that's categories including things that have characteristics. For example, names, ages, locations, occupations, personal preferences, for example, food, clothes, leisure activities, colors. A two-way table organizes data about two categorical variables. So something about talking about the categories up here. A frequency, how often something happens. So then when you do a relative frequency table, it's how often something happens divided by the total outcomes. And in a relative frequency table, your table is all decimals, and your total on a relative frequency table, your total is 1, where on a two-way table, your total varies. Could be 100, could be 350, could be 1,000, who knows? It varies. All right, let's practice. Now, we did the Venn diagrams yesterday. The Venn diagram here shows the 350 students, the number of students who chose option 1, option 2, or both for lunch. All right, looking at the two-way table down here, off of this Venn diagram, how many chose option 1 and option 2? Option 1 and option 2 was 37. How many chose option 1 but not option 2? So here's our option 1 circle. How many chose option 1 but not number 2? 84. Now what we do, we go across and we add these up in our totals. What's 37 plus 84? What does that equal? 121. All right, how about this column? Or excuse me, this is a row. These are our columns. All right, when you're referring on tables, these are rows. These are columns. So let's do the second row. Who didn't choose number 1, but chose option 2? Now we're looking at this one. Didn't choose number 1, but chose number 2. So they didn't choose number 1, but they chose number 2. Yep, 139. Now we could fill in this square because the total's going down in this column. What is 37 plus 139? Yep, 176. Now, we have a total column here and a total column here. What is our complete total that should be in this corner? We can fill that in if we wanted even before we started. How many total? How many total people were in here? 350. Should be in there 350. That should be our total. All right. Now, so basically, could I fill in this one without looking at the Venn diagram now? I could take 350 minus 176 and get this answer. Or let's just keep going off of the table. How many didn't choose number 1 and didn't choose number 2? Do we know that other number in our universe that's missing? No. What is 84 plus 37 plus 139? You add those up, you get 260, right? And our total was 350. This is what we did yesterday on our Venn diagrams. What do I get when I subtract? You get 90. So now I add up all my numbers inside my Venn diagram and that 90 in the universe, it equals 350. So the ones that did not choose anything were 90. What do I get when I take 139 plus 90? What does that equal over here? Yep, 229. Does that work out then? Is 121 plus 229 350? Did we do that right? Yep, we did. All right, now we're just missing this number. How many are totaled here? 84 plus 90 is what? Yep. So now if I go across, our 176 plus 174, does that equal my 350? Yeah. It does. So we know we did it right, because all of these 2 equal 350. These going across in this row equal 350. You're done. The two-way table. Numbers only, and it equals your total. And this could change in every problem. Example number 2 in a recent survey of 100 people. So where can I put that 100? A total of 100 people were surveyed. Right here, we know our total is going to be 100. In our two-way table, my total has to be 100. Let's fill in our Venn diagram. We have people that like Macs. We have people that have a PC. What do I know? 45 people have a Mac. Do they have only a Mac? Or where should I put that? On the outside. We know that this circle has to equal 57. How many PC people do we have? Oh, my bad. I put the wrong number there. 45 people have a Mac. 57 have a PC. So that's on the outside because it doesn't say only. 12 people have both a Mac and a PC. Where does that number go? In the middle. Yep, right here in the middle. Now, what else can I fill in on this Venn diagram? I need to do what function? Add, subtract, multiply, or divide? Good. 45 minus 12 gives me 33. What's 57 minus 12?
45.
Good. Now, what am I missing in my universe? Out of these 100 people, how many are missing in my universe that don't have either? What's 33 plus 12 plus 45? 90. So what's 100 minus 90? So what does that tell me? 10 people that what? 10 people that don't have either a Mac or a PC. Because now my 100 people are all accounted for in my universe in my Venn diagram. Now let's fill in our two-way table. A two-way frequency table. How many own a Mac and own a PC?
12.
How many own a Mac but no PC?
33.
Yep. What's my total? What do I add these up and get? 45. How many have no Mac but they have a PC?
45.
Good. How many have no Mac and no PC at all? 10. That was what we figured out here. What's my total going across in that row?
55.
55. Let's do a quick check. Does 45 plus 55 equal our total of 100? So it's looking pretty good right now that we have the right numbers in the right places. Let's check these totals out. What's 12 and 45?
57.
33 plus 10?
43.
All right, is 57 plus 43, does that equal 100? It does. That means we got it all to work out. Excellent. So how many only have a Mac?
33.
33. How many only have a PC?
45.
Nice. Both?
12.
How about neither?
10.
And the 10. Nice job. All right, now in example 3, I've given you some numbers in the table, the two-way table. Let's fill in our totals. It says the following two-way frequency table shows the favorite leisure activities of 50 males and females. So what is that 50? 50 should be our what?
Total.
And that goes where?
Bottom right.
Yes. Now let's see if this works out. Are there any errors in this table? What is 7 plus 5 plus 12? 24. What is 13 plus 4 plus 9?
6.
If I add these together, do I get 50? Whew.
Yeah.
So far, so good. 7 plus 13 is?
20.
5 plus 4, 12 plus 9 is 20 plus 9 plus 21. Does that equal 50? It does. So the numbers are correct. There are no errors. Now, off of that two-way table, let's go and take this same information and put it down here in a relative frequency table. And on the front page, I talked about what is the total of a relative frequency table. It doesn't change like a two-way table. On a relative frequency table, your total is always what? Which is always what? 1. Because we're working with decimals. We're going to see the percent of the total outcome. So now we take this one. Male that likes sports is 7. 7 out of how many?
24.
Out of a total of 50. So on your calculators, you take 7 divided by 50, 0.14. Now on some of your relative frequency tables, you might get long decimals. If that happens, round them to the nearest 1,000. So you'd have 3 decimals. But these come out to nice decimals that are in the 100. So you'll have 2 decimals. But if you have to round them to 3 decimal places. Round them to the nearest 1,000 if needed. And you'll need to do that on your homework. So what's this one? 5 divided by 50 is 0.1. Some like to write 0.110 or 0.10. Up to you. All right. What's 12 divided by 50? Anybody notice what's going on here? Because it's out of 50 and out of 100, it's half. All right. So you take it times 2. So what do I get when I add these across? 0.14, 0.1, 0.24. What does that equal? Yep, 0.48. All right, now let's do this one. What is 13 divided by 50? 0.26. All right, what is 4 divided by 50? 0.08. 9 divided by 50? 0.18. Add these all up going across, please. What do you get? Point 5 what? 2. Now hopefully, does this one plus this one equal 1? Awesome, then it's correct. Let's see if we did these right now. If this bottom row will equal 1. What is 0.14 and 0.26? You get 4/10, or if you want to write it as 40 hundredths, doesn't matter. Here you get 18 hundredths, and here you get 42 hundredths when I add these two up. Now, going across in this row, does 40 hundredths plus 18 hundredths plus 42 hundredths equal 1? On your calculators, if you add those all up?
Yeah.
Yes, it does. Because our magic number has to be 1 when it's a relative frequency table. Okay, last example. Example 4. The following two-way frequency table. The number of students ages 10 to 13 and 14 to 17, so we have our 2 categories here. These are our 2 categories that like to eat breakfast or skip breakfast. Now they went and put in some totals for us that they knew. But now let's put in some additional information. It says 29 10 through 13-year-olds eat breakfast. Or should I put that number 29? What row? In the 10 to 13-year-old row. And do I put it here under eat breakfast or skip breakfast? Right. And what number goes here? 29. 29 10 to 13-year-olds eat breakfast. So I put that one on there. Where do I put the number 22? 22 14 to 17-year-olds skip breakfast. So I go into the skip breakfast, put it here, 22. Now we can find our missing numbers just by having those on there. How can I find this number right here? I subtract. I can either take 38 minus 29, or I can take 31 minus 22. You should get the same answer. What is 31 minus 22? 9. What's 38 minus 29? 9. All right? So we can find that answer. How do I find this one? Yep, I could take 37 minus 22 or 44 minus 29. I should get the same answer. Check it both ways. What do you get? You get, no matter which way you do it, you get 15. All right, so adding them up across, what's 44 plus 31? 75 is the total number of students that were surveyed. Now we're going to make our relative frequency with this information. So what's my first decimal going to be? We're going to take 29 and divide it by what? 29 and divide it by the total, 75. So 29 divided by 75 is, round it to the nearest thousand. And 0.386 repeating rounds to 0.387 to the nearest thousand. All right, what is 9 divided by 75? That won't go to the nearest thousandth. I think that just rounds off. It terminates, doesn't it? At 1200ths. Okay, add these up. What is 387 thousandths plus 1200ths? What do you get? You get, say it for me. 507 what? Thousandths. 507 thousandths. All right, how about here? 14 to 17-year-olds. 15 divided by 75 is? 2. 22 divided by 75 is? Rounded. 293. 0.2 plus 0.293 is? 0.493. And if we did things correct, when I take this and add it to this, what will it better equal? It needs to equal 1, does it? Yes, it does. So far we are liking our math assignment because so far that is correct. What is 0.38 plus 0.2? Or 387 plus 0.2? 0.587. And here we're going to get what? 0.413. Do these, the final check. Does 587 thousandths plus 413 thousandths equal 1? It does. So we know we are correct. All right, your assignment is pages 4, 5, and 6.